My name is Muhammad Farhan bin Muhammad Nasir. Introduction of IBS. The Industrialized Building System IBS is a modern construction method which a construction technique in which components are manufactured in a controlled environment either on or off sites. The components are transported, positioned and assembled into a structure with the least of additional site work. It is also known as prefabricated or prefab construction, modern method of construction MMC, and off-site construction in the rest of the world. We will explain about the most common group of IBS is precast concrete, including column, beam, slab, and roof. 3D dimension 3D constituents such as balconies and staircase. This study also carried out to cast precast element at the factory and the method of installation of precast elements. Moreover, the study was carried out at Klinik Kesihatan Tu Tampin, Negeri Sembilan. This project is managed by JKR and has 6 buildings that are being developed. The total value of this project is 37 million and this project is still running. This project is estimated to be complete in 2026. In constructing the project, the most important problem to be considered are the settlement and stability of the column, slab and beam structure.
TCR Precast Sendirian Berhad, the fully Bumiputera-owned company founded in 2009, is based near Parai and Seremban with easy highway access. It specializes in precast concrete and offers a complete IBS solution from design to installation. The company supports the government's global promoting Bumiputera entrepreneurship, values strong communication for project success.
Next, me and Ziyad will continue with explanation of construction technique. First stage is design stage. It needs to get approved by engineer. After the design got approval by engineer, it will continue with manufacturing stage. Next is transportation stage, where the item will deliver to site to assemble the part. Lastly, after the item arrive at site, it will continue with assembly process.
My name is Ziyad Iskandar Mizamas. Today I will talk about method of construction and specification applied. First is design and planning. Detailed design drawings and load calculation are prepared by structural engineers before casting. Selection of precast elements like walls, beams, slabs is done based on structural and architectural requirements. Then, connection details and tolerance are incorporated into the design. Next is mold preparation. Molds are fabricated using steel, timber, or fiberglass depending on the shape and required finish. Molds also include necessary provision for reinforcement, openings, inserts, and lifting hooks. Reinforcement and embedments. Reinforcement cage are fabricated and placed inside the mold as per design. Additional embedded items such as electrical conduit, lifting anchors, and connection inserts are positioned. Then is concrete casting. High quality concrete is batched and poured into the mold. Vibrators are used to compact the concrete and eliminate air pocket. Finishing done on exposed surface as per architectural specification. Curing. Curing is carried out under controlled condition to achieve rapid strength gain. Proper curing enhance durability and minimize cracking. Next is demolding and inspection. After achieving sufficient strength, elements are demolded carefully. Surface defects, if any, are repaired and elements are visually inspected and dimensionally checked. Next is transportation and handling. Precast elements are transported to the site using trailer or crane. Proper care is taken to avoid damage during handling and loading or unloading.
There is a lot of machineries and equipment used for this project, and that is mobile crane, spreader beam, vibrator, concrete saw, line laser level, pallet truck, hammer drill, bar bender, measurement tape, marking ink and thread, plumb bob and thread, echo wheelbarrow, hand pump, electrical mixer, mixing drums, crowbars, trowel, spirit level, cutter machine, foam rod, bucket, wire, rebar, rubber strip, shim plate, prop, mold, and grouting.
Problem of using precast concrete. Firstly, complex machineries. The construction of a precast concrete manufacturing facility requires huge physical investment. High-tech equipment costs a lot of money and demand high investment. The answer to this problem is to ensure that building projects are audience size big enough to earn an amount of revenues that match the original investment required. Secondly, installation process. One of the main elements that ensure that a building continues to perform favorably is the assemblage of the precast units. In order to make the connection reliable, there must be appropriate supervision and completion of connection between several structural pieces which are simple, semi-rigid or firm. Lastly, transportation. Workers must ensure to handle precast concrete components carefully to wear and tear. Manufacture of precast part takes place in factories which may or may not be located very near building sites. Precast components need to be transported to the site construction areas, hence necessitating the use of trailers. The precast part or components are usually very large or have enormous proportion, making it challenging to transport or carry it.
Next is solution. Precast concrete offer many benefits but also come with challenges. To overcome this, here are 3 key solutions that ensure successful implementation in construction projects. First, precast concrete require high-tech equipment and significant investment. So, it's important to use this method for large-scale projects like public infrastructure, commercial buildings, or residential township. This way, costs can be spread across many units, making each component more cost-effective and improving overall profitability. Next, the quality and durability of precast structure depend heavily on proper installation. Poor connections can lead to insulation issue or water leaks. That's why it's crucial to employ skilled workers who follow exact instructions for linking and sealing each component. Proper supervision also helps ensure consistent quality and avoid structural problems. Lastly, transporting precast components can be challenging since they are often large and heavy. To solve this, we use special carriers or trailers for safe transport at the site. Good planning and instructions help workers place each unit correctly to avoid misalignment or damage.
Application in real world. Firstly, affordable housing project. The Malaysian construction authorities are trying to employ modern machinery and encourage the adoption of new practice of construction to meet the plans made by the government. IBS is frequently used in government-funded low-cost housing projects. Secondly, green buildings and sustainable development. By incorporating into policy intervention on green buildings, IBS, like any other element, become part of the maximum sustainability objective. Also, the component can be designed with energy-efficient materials and technologies. Third, standardization and quality control. Government use IBS to ensure the same quality of building in their project constantly. Due to the fact that the parts are manufactured in controlled factory conditions, the possibility of defect or variability in quality is minimized, hence making the structure stronger and safer. Fourth, cost and time savings. Construction using IBS can reduce time and cost and IBS production can be started with the earthworks after design approval. Fifth, reduce dependence on foreign labor. The use of IBS can reduce dependence on foreign labor, particularly skilled and unskilled workers. This will overcome the problem of the influx of foreign workers in Malaysia. Regulation of precast concrete. CIDB guidelines. The Construction Industry Development Board (CIDB) Malaysia has implemented the IBS core system, which is derived from the Construction Industry Standard CIS 18 to control and facilitate IBS. Uniform Building Bylaws (UBBL). The scoring system developed by the CIDB, IBS has to be in line with various national laws, including UBBL obligation. In this bylaw define fire safety, structural stability, ventilation, accessibility, and other important elements of the building design. Occupational Safety and Health Administration (OSHA). It is provide worker safety when producing the IBS component and as well when they are finally installed at the construction site. IBS in fact reduce the risk of falls, accident, and injuries, despite the fact that a portion of the construction work is transferred to regulate factory settings. Building Materials Regulation. To guarantee quality production and adherence to the building material construction, the IBS component should be produced in line with the Malaysian Standard MS or International Acceptable Standard, to include British Standard BS.
Next is sustainability aspects related to IBS. For the first one is waste reduction, less construction waste due to factory-made components. Reduce cutting errors and on-site modification, cleaner sites and lower disposal needs. Second is material and equipment efficiency. Use standard and recycled materials like steel, precast concrete, and lightweight panels. Materials can be used in multiple projects. Precise design and production reduce over-ordering of materials. Energy or manpower on sites. Less on-site work reduce carbon emissions and fuel use. Fewer transport trips or labor and materials. Shorter construction time, lower energy usage on sites like machines. Reduce environmental pollution. IBS helps meet green building standards like GBI and Precast. Encourage energy efficient design and reduce environmental impact. Support green certification through better insulation, material efficiency.
In conclusion, the Industrial Building System or IBS brings many positive change to the construction industry. It improves safety, quality, and efficiency for both workers and structures. This report has been shown how IBS, especially in government projects, help produce and install precast concrete components more effectively. However, IBS requires careful planning, skilled workers, and a shift away from traditional methods. Looking ahead, IBS has strong potential to shape the future of construction, offering faster, greener, and more cost-effective solutions for developers and in the industry.